Good evening, everyone. Today we're going to take a look at one of your week 3 section 1 homework assignments about the S&P seismograph travel times. I apologize for the quality of this video. I'm having to do this on the fly with the baby in the next room. So here we go. I've made a copy of the page that we are talking about so that I can write on it with you. What we're talking about here are 3 readings of seismographs that were taken in Sitka, Alaska, Charlotte, North Carolina, and Honolulu, Hawaii. And we're reading about when the S waves and the P waves first arrived. Now, one quick, easy way that I've always remembered which comes first is that P comes before S in the alphabet. And in this case, it also is always P comes before S with earthquakes and seismographs. So P waves are always going to be the first to arrive, which is what you're seeing right here. These are P waves. And then S waves are our second arrival, which is right here. So what we're going to do is take a look at this chart. You can see here at the bottom we've got times 806, 807, 808, 809, on and on. These are the times that were recorded as the waves were recorded at these various locations. Over here we have Sitka, Alaska, Charlotte, North Carolina, Honolulu, Hawaii. Okay, so here we have, it's asking us here at the bottom, estimate to the nearest tenth of a minute the times that P waves and S waves first arrived at each recording station. Then we're going to subtract to get a time interval. So first we need to know Sitka's P arrival. When we look here, this is the very first wave. And if we go down, we'll see that that's a little bit past 807. I would say, just eyeballing it, it's about 807 and a half. The instructor manual is very specific and it calls it 807 to the 0.4, which, whatever. This doesn't have to be exact. So 807 and a half is what most of you probably would come up with. And that's what we're going to write on our first P arrival is 807.5. So you can see I've written that. And then our first S arrival would be, so all this are P, 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 and then you can see a big change here, and this is S. So we're going to go on down. I don't know what my camera is doing right now, trying to autofocus, sorry. We'll move on down, and you'll see 810, 811, probably and a half. So 811 and a half. I'm writing that down. So here we have 807.5 was our first P arrival, 811.5 is our first S arrival, and we subtract that and we get about 4 minutes. So that's our S minus P. Now you're going to do that for all 3 of these, but I'm just showing you how to do the first one. And then the next thing says, using the S minus P time intervals and travel time curves found on figure 16.5, determine the distance. Okay, so here we go. We're going to take a look at what page that is. Dumb autofocus again. This is page 353 in your lab book, figure 16.5. You'll see this weird chart that has these graphs already graphed on here. And what this is letting you know is it already has some lines for you. This is indicating the P wave, the S wave. This particular graph also is going to deal with L waves, but we're not going to deal with those today. We're just going to deal with P and S. Okay. So let me try to see if you can see what I'm doing here. We're going to zoom in here. At the very bottom, we have the distance to the epicenter in kilometers. So 0 to 1,000, 2,000, 3,000, 4,000, and so on. And you can see I've labeled for you the P, the S, and the L waves. And when we look back over here, we have over here on this axis the travel time in minutes. Now we just dealt with this with Sitka. So if we go back to our page, you'll see our S minus P travel time was 4 minutes. So that's going to be our starting point. We're going to come over here, and what I have found in the past is the easiest way to do this is to use a little piece of paper. And what you're going to do is actually line up, sorry, I'm not used to trying to hold an iPad and do this at the same time. You're going to line up this at the edge of your graph, and you can see that 5 already exists there, but we're going to need to add 1, 2, 3, and 4, and 6. I just went ahead and added that just for the ease of, I know how far we're going to have to go on this certain problem. So we're dealing with 4 minutes. Let's make a little line right at 4. And now we've got these lines we've got our P line and our S line. And all you're going to do is simply line this up on that bottom line, keeping it vertical. And keep following that line. Keep going until it matches up. So you can see when you're holding the bottom, it is lined up with your P and your S. When that lines up, go down, and that's your distance. So that's about 2,700 kilometers. So we can go back to our paper. And that's, I can't write with you looking, sorry, I suck at that. So then we have 2,700 kilometers. And then you're going to do the same thing with Charlotte. You're going to figure out your P and S just like we did up here. You're going to take our subtraction. You're going to come over here. You're going to line up your paper. You're going to make a mark on however many minutes it is, which I can tell you you're not going to go over 6 on this assignment. And then you're going to follow this all the way until that line at the top matches up with you holding it at the bottom. And then you'll go down and you'll see how many kilometers that is, and that's your answer. If you have any questions, feel free to post it. Again, sorry for the quality, but I hope this helps. Talk to you later.